In this short lesson, I want to talk about designing data transfer objects. Let's start by thinking of the different representations of data inside the application. Each layer in my application has different needs or is working from a different agenda. And as a result, while the general concept of the data is the same across all the layers, for example, a customer or order has the same general representation across all the layers, the classes that represent these concepts may look different between the layers due to the needs those classes are trying to satisfy within the given layer. So first, let's take a pass and look at the agenda of each layer and the data it works with. First of all, the persistence layer. I've already said I would use the entity framework to implement this layer today, and if I'm working with the entity layer, then I'm working with a DB set of entities. The DB set of entities, at least by default, if you allow Visual Studio and the Entity Framework Designer to have their way, the organization of the properties of the entities will wind up looking a lot like a relational database table layout. All right. Then there's the domain layer, which works with domain classes. If we model these correctly, they embody the best object-oriented analysis and design we can muster. As such, these typically will have both properties and methods. They encapsulate and embody the problem domain's notion of a given idea, a customer, or an order. They have relationships with other classes, including aggregate relationships and composite relationships in some cases. And then consider the presentation layer. It works with a view model, and this is presentation-specific data. Because of the way that end users want to view the data, you may not have a clean separation between the notion of a customer and order. They could be all kind of mixed together based on what the end user wants to see or do in a given page view or of a screen of an application. In other words, the data could be much flatter in a view model than, say, in a persistence layer or domain layer class. So again, each of these layers have their own needs and they have their own agenda. If we settle on a single layer's view of the world and we try to pass that between the various layers, then we risk a leaky abstraction. But we want to avoid leaky abstractions because our layer should be cleanly separated to improve each layer's ability to absorb change. For example, if I were to pass the DB set of entities up all the way through the layers until it's used in the presentation layer, now we've coupled our entire application to the entity framework, and we don't want to do that. If we were to pass our domain classes around through all the layers, each layer would now know too much about the domain layer. It would not only see all the public properties, but it would also see all of the chatty methods that we've created in those classes. If we were to pass the view model down through the domain and persistence layers, it might be missing important, non-visible, but crucial data points needed for domain logic and missing data points needed for persistence. Okay, while it's not expedient for us to use any of the current options, whether it's the DB set of entities, the domain classes, or the view model between the layers, you've got to pass something between the layers. So what do? Well, actually, some architects and developers choose to do exactly what I've suggested. They pick either the domain classes or the DB and DB set entities or the view model as the main container to pass data between the layers. That's one option, and the benefit of it is that, hey, you've already got those classes defined. You don't really need to do any extra work. You would just continue to pass those through the other layers. However, in many cases, what architects decide to do is to identify that there's a new concern here, a different concern. So they create a special set of classes, a new layer of classes, specifically for the purpose of transferring data between the other layers. They call these data transfer objects. These objects have a specific purpose, and that is to transfer data between other layers. And so the composition of these classes is pretty much public properties and almost nothing else. They just have properties. And frankly, many DTO classes, data transfer object classes, look a lot like the domain classes or the DB set of entities or whatever. They have many of the same properties. They have many of the same associations because they're ultimately representing the same concept, a customer, an order, whatever the case might be. However, data transfer objects make sense if you really want to, first of all, keep the different responsibilities of your classes clear and distinct. And also because you want to design data transfer objects that allow you to, like we talked about in the previous lesson, consolidate data structures for passage between the layers, especially if those layers are distributed on different tiers, in which case you would want to use pure POCO objects being distributed between the layers so that they can easily be serialized into XML or any other data format. And so you'll recall from the previous lesson that we're striving to reduce the number of calls between layers for two reasons. Because first of all, if those layers are deployed to different tiers, the network chatter will have a negative impact on our application's performance. And then secondly, because if we rely on one layer making many calls to chatty, limited scope methods, then that calling layer may come to understand too much about the implementation of the supporting layer. So for example, we don't want our presentation layer making multiple calls into our domain layer, right? So we want to minimize that. If it were to try to make a dozen calls to get the information it needs, we have a high degree of coupling. It knows too much about the domain layer, and that domain-specific knowledge would have to be repeated if we re-implement the presentation layer using a different technology. Instead, we prefer to insert an application services layer with chunky methods for this very reason. Those chunky methods handle orchestration of the lower level, finer-grained, chatty methods to perform the necessary work in the domain layer. In some cases, what gets passed back from the application services to the presentation layer will be a lot of data, perhaps even different kinds of data, perhaps even unrelated instances of domain entities, domain classes. So creating a customized data transfer object that holds all the disparate data could be a means of serving everything the client needs, in this case, the presentation layer. Everything it needs in order to display the appropriate screen to the user all in one shot, in one method call, and in one response. And while I'm specifically picking on the relationship between the presentation and the application services and domain layer, this is true in all interactions between layers. Designing chunky methods means designing the return types, and those return types should be chunky in scope as well, returning everything the caller needs from the method in one call, minimizing the need for round trips. So assuming that you're going to be working with data transfer objects, you're going to have to map the properties of a given class, whether that's a DB set of entities, a domain class, or a view model. You're going to have to map those values to properties in your data transfer classes so that you can then send them between the layers, right? So you'll have to map the properties of entity objects in the persistence layer to properties of the data transfer specific classes. And so you can write all that code by hand, or you can use a handy open source utility called AutoMapper to do this. And so if you take a look on screen right now, there's the URL where you can learn more about AutoMapper. And their Getting Started guide shows a common mapping, and it's really simple to do. You basically just need to do this once inside of the application. You create a map and you send in the source and the target. So the source may be your order entity, and the target is a data transfer object, a class used for data transfer that also transfers the order. Okay, and so then to actually use the mapping, whenever you're doing the actual mapping between the two, you merely call that same map, passing in the generic order and order DTO, and then you pass in your instance of the order entity, and then it will map it out to this order DTO over here on the left-hand side. So as long as the property names in both the order and the order DTO are the same, it can automatically perform the mapping. However, if the property names are not the same, or if you have to do what's called hand-rolled mapping, then their wiki gives a few examples for different scenarios, and it shows you how to basically make this work despite the fact that you have a more complex scenario. But here again, we're speaking purely in conceptual terms. What you probably would like to see is a real example. I would say this for now. Let's just keep this thought in mind, and then later when we build the example application in the second part of this series, we'll examine this topic of what to pass between layers and how we'll go about doing that and how we'll go about the mapping between the DTO objects and the native classes for the given layer. Okay, so to recap, we've established in a previous lesson that we should pass simple types or POCOs or generic collections of POCOs or even entire object graphs between layers. We have to choose what POCO classes to use. We could use the domain entities if our needs are simple, or in this lesson I suggested that we could create custom POCO classes specifically for the purpose of transferring chunky data between layers. Kind of the other side of the coin to creating chunky, coarse-grained methods to minimize the amount of chatter between the layers. If we take this strategy, we'll have to write a lot of mapping code, mapping properties of one class to properties of another class, and we could write this all ourselves by hand, or we could just take a few minutes to learn this AutoMapper utility that I talked about, which will alleviate this effort. And so we're going to use this whenever we come to write our own example architecture. All right. So in the next lesson, we're going to talk about dependency injection, since I've hinted at it a couple times, and since it's kind of crucial to what our plans are going forward with our own architecture. So I'll talk to you in the next lesson. Thank you.